Hello everyone, myself Bhavani, Assistant Professor in IT Department.
Now moving on to independent and dependent variables. Independent variable is the cause or input factor. Dependent variable is the effect or output factor. Dependent variable change is due to the independent variable used widely in experiments and research studies. Examples study time versus marks. In this study time will be independent and marks will be dependent. Help in understanding relationship between variables. Okay. Clearly, we can see that independent variable that is changed, controlled, or selected by the researcher. Okay, it influences or predict another variable, also called predictor or input variable. Example: study hours, temperature, or advertising budgets all comes under the independent variables. Now moving on to dependent variable. This is observed or measured. It depends on the independent variable, also called response or output variable. Now, like example for dependent variable will be exam scores, ice cream sales or sales revenue. These all comes under the dependent variable. Okay. Now moving on to types of variable measurement scale. Four major scales: nominal, ordinal, interval, and ratio. Nominal classifies data without order. Ordinal scale provides ranking but unequal differences. Ordinal scale, interval scale as equal intervals but no true zero. Ratio scale as equal intervals and an absolute zero. Choice of scale affects statistical technique used. Okay. See, clearly, it has been defined how data is measured or classified is called measurement scale. It determines the type of statistical analysis that can be applied to the data. In this, types of measurement scale is also there. It includes nominal scale, ordinal scale, interval, and then ratio. Nominal scale, it categorizes data without any order. Only equality, inequality can be identified. Example, gender and blood group. Ordinal scale categorize data with a meaningful order. Difference between values are not measurable. Example, satisfaction level, education level, class rank, which has three categories: low, medium, and then high. Interval scale, numerical scale with equal intervals, no zero true point. Example, temperature and calendar years. Ratio scale with equal intervals under true zero. All mathematical operations are valid. Okay. Example, height, weight, age, and then salary. Now we are seeing about the describing data with tables, frequency tables. Frequency table shows how often value occur, summarize large data set into compact form, include classes, frequency and cumulative total, used for both qualitative and quantitative data, help in identifying distribution of observations, forms the basic for graph and chart. See. Frequency table is a simple and effective way to organize and summarize data by showing how often each value or category occurs in a dataset. Like frequency table is data values or class intervals. Like frequency means number of times each value is occur that has been calculated is called frequency table. In this, there we can define the types of frequency table. It is simple frequency table, group frequency table, relative frequency table, cumulative frequency table. First, we can see about the simple frequency table. It is used for discrete or categorical data. Okay. Example, mark obtained by the students. See, mark will be 40 and frequency will be 3, like that. 50 marks means frequency will be 5, like that. Group frequency table used for continuous data grouped into class interval. Like example, class interval 0 to 10 means frequency will be 4. Relative frequency table shows frequency as a percentage or proportion. Value A, frequency will be 20, and relative frequency. Cumulative frequency table shows the running total of frequencies. Class interval, frequency, and then cumulative frequency. 0 to 10 will be the class interval, and then frequency will be 4. Cumulative frequency also 4. Advantages of frequency table: easy to understand and interpret, help identify patterns and trends, form the basic for graph like histogram graph or bar chart. Okay, these will be comes under the frequency table. Now moving on to cross tabulation. Cross tabulation composes two categorical variables, displays joint frequency distribution in a table format, useful for relationship and pattern identification, widely used in market research and social science, shows count of percentages across categories, support further statistical analysis and testing. This is a method of summarizing and analyzing the relationship between two or more categorical variables by displaying their frequencies in a table format. Like, let me discuss about the what is cross tabulation. Actually, it shows how the categories of one variable intersect with the categories of another variable, making relationship easy to observe. Okay, there are some key features for cross tabulation. Rows represent categories of variables, column represent categories of another variable, cell value shows frequency counts. Okay, in this we can see about the uses of cross tabulation. It can be identify relationship and patterns between variable, compares group, useful in survey, research and data analysis. There will be three types: two-way table, multi-way table, percentage, crosstab. That's all. Now moving on to describing data with graph. Graph provide visual representation of data, help in understanding trends and comparison. Common graph include bar chart and pie chart. Line graph are useful for time series data. Histogram shows frequency distribution of data. Graph make interpretation easier and intuitive. See, nothing but describing data with graph means using visual representation to summarize, explore and communicate pattern, trends and relationship in a data clearly and effectively. Actually, we need to know why do we need to use graph in this. Easy to understand the tables, quick show the pattern and trends, help to compare the values, used for presentation and decision making. There are some type of graph like bar chart, histogram, pie chart, line chart, scatter plot, box plot, etc. Okay. Now moving on to describing data with graph. See, bar and pie chart. This is also the one type of chart. Bar chart compare categorize using rectangular bar. Bar may be vertical or horizontal in orientation, useful for quantitative or discrete quantitative data. Pie chart displays proportion of categories as slices. Each slices represent percentage contribution, best used when total value and parts are compared. And then we are moving on to graph like histogram and then polygon. This is also one of the type of graphs comes in the graph. It displays group frequency distribution. Bars are adjacent with no gaps between them. Useful for continuous qualitative data analysis. Frequency polygon joins midpoints of class intervals. Both tools help visualize shape of distribution, important for identifying skewness and spread. Now describing data with averages. Okay, if we need to find averages, in that we can calculate the number divided by total. This is the easy way to find the average. It represents the central or typical value of data. Summarize large data into a single value. Common measure include mean, median and then mode. Used for comparison between data set. Provides meaningful interpretation of data trends, help in decision making and reporting. See, mean. It's a arithmetic average. Same. Likely we need to find the average. Okay. Average means will be totally add and divided by the sum. It gives you the mean value. Mean is the sum of values divided by the number of items. Same. Most commonly used to measure of central tendency. Sensitive to extreme high or low values. Useful for numerical and continuous data. Represent balance point of data. Widely used in economic science and research. And then moving on to median and mode. It is the middle value of an ordered data set. Not affected by extreme value of outliers. Useful for squared distribution and ranked data. Mode is the most frequent occurring value. Can be used for both numerical and categorical data. Helpful for identifying dominant group or values. These will be for median and mode. And then describing variability concept. It shows how data values spread around the center. High variability means values are widely scattered. Low values are closely clustered. Measures of variability complement averages. Important measures include range and variance, used to access consistency and stability of data. And then moving on to range and variance is the difference between highest and lowest value. Affected by extreme value or outliers, variance measures average square deviation from mean. Higher variance indicates greater data depression. Used in probability, risk analysis and quality control, forms basics for calculation of standard deviation. See, standard deviation ST is the square root of variance. This is the formula for ST. Expressed in the same unit as original data. Indicates average distance of values from the mean. Low standard deviation means value are close to mean. High standard deviation shows large spread of data. Widely applied in statistics, finance and research. And then moving on to normal distribution is a symmetric bell-shaped curve. Mean, median, mode are equal at the center. Most values lie close to the mean in the middle region. Probability decreases as value move away from mean. Many natural and social phenomena follow this pattern. Important foundation for statistical inference. These will be normal distribution. And then important topic, standard z-score. It measures how many SD a value is from mean, calculated by subtracting mean and dividing by ST. Positive z-score indicates value above the mean, negative will be below the mean. Help in comparing values from different datasets. Useful in probability calculation and hypothesis testing. Okay, let us see about the summary and conclusion for this unit 2. It has been reviewed about the data science process and application. Okay, thank you.